Hi, welcome to Lesson 6B. This is actually the continuation from Lesson 6A because I'm doing 6A and B together. So we're looking now at the general term of a number sequence. How do we actually determine each term by its term number? We saw a couple examples in the last video regarding the rule that was used to produce each of the previous terms. One of the examples was using some mathematical rule by dividing by 2, each term by 2 to get the next term. The second example, we were dealing with the term number to get each term. So we're going to be looking a little bit more in depth at finding the general term in the next lesson. But this one I just want to kind of briefly go through it because we're just going to be using general terms that are given to us to evaluate each of the terms. So it'd just be more of a calculation kind of thing exercise today. So let's take a look at this term here, this sequence. We've got term 1 is -5, and I've listed this down below here also. Term 2 is -1, term 3 is 3, term 4 is 7, term 5 is 11, term 6 is 15, and term 7 is 19. Now, each of the term numbers themselves have to be integers. So we can't have a term 0, even though a 0 is an integer. It starts at 1 for term numbers. We cannot have, a term 1.5 or a term 2/3. You either have a term or you don't, and so they're discrete values of terms. And each term, as you know, it's kind of like its own little mailbox. It's kind of in a specific slot in a specific position. So -5 is term 1. -5 cannot be term 2 or in any other position. -1 is term 2. 3 is term 3, etc. Okay. So just down below here are just different ways to kind of discuss or name which term is which, sort of thing. To find a general term dealing with the term number sometimes can be kind of challenging. Now this one is not obvious at all. Other ones, you have term 1 is 1 and if term 1 is a 2 and term 2 is 3 and term 3 is 4, then we can say, okay, well, we're adding 1 to each term number. Well, that's fine. This one's a little bit more challenging, and I kind of had to jump ahead to the next lesson on arithmetic sequences to come up with this general term. So don't be too shocked when you see what the general term is in this case. As it turns out, the general term is described by u sub n is 4n minus 9. So if we take a look up here, 4n minus 9, well, if term 1 is 1, well, the n is 1 for term 1, and we substitute that 1 in for n here. 4 times 1 is 4, minus 9 is -5, just as we have in the actual sequence. Then if we go on to term 2, we substitute 2 into here. 4 times 2 is 8, minus 9 gives us -1. And if we were to substitute in 3 in for that, 3 times 4 is 12, minus 9 gives us 3, etc., etc. Okay, so this is the correct term, or the general term. Developing that sometimes can be a little challenging, but I'll take care of you in the next lesson in 6C. All we really have to do now for this lesson is just kind of use the general term and substitute values in to evaluate other terms. So if the sequence is defined by 4n minus 9, We want to find u3, u sub 3, so we'll substitute 3 in for n. So we have 4 times 3 minus 9, and 4 times 3 is 12, minus 9 is 3, just as we saw above. Then for u sub 15, the 15th term, we substitute 15 in for n. So we have 4 times 15 minus 9. 4 times 15 is 60. Minus 9 gives us 51. So that's about it for the first example. The second example then is we want to do the same kind of thing, but we want to evaluate the first 5 terms of that sequence. So we just have to substitute in 1, 2, 3, 4, and 5 in for n and evaluate each of those. So 1 times 2 is 2, minus 1 gives us 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. After you get a couple, 2 or 3, you start to see, okay, well that's plus 2, plus 2, plus 2, plus 2. So, I mean, not that multiplying by 2 and then subtracting 1 is difficult, but sometimes if you get something that's a little bit more challenging, it may be easier to see what each term is going up by, just to continue the sequence, especially if you have to do more than 4 or 5 terms. Okay, so that is that sequence. And now we move on to evaluating the first 5 terms of this sequence here. Okay, so here we have an exponential, 2 to the power n, and then once you calculate that, you multiply by 3. So can I ask you to pause the video, please, and work on this one, get the first 5 terms of the sequence, and then come back and play the video again to see what I have come up with for those first 5 terms. Okay, so now that you've done that, if I were to substitute 1 in for n here, 2 to the power 1 is 2. 2 times 3 gives me 6. Then 2 to the power 2 for the second term is 4. 4 times 3 is 12. Then for the third term, 2 to the power 3 is 8. 8 times 3 is 24. Now I see that each of the terms I'm just multiplying by 2 each time, as is obvious with the power. And so then I get 48, and then 96. So those are the first 5 terms. And like they say, Bob's your uncle. Here's your work at the bottom. Page 153, do those set. 154, do those. And then come on back and we will do lesson 6C, which is arithmetic sequences. So thank you for your attention for both this video and the previous one, 6A, and we'll see you in class.